On Software Engineering Daily, we have seen the improvements that software is bringing to every domain, from insurance to food engineering, from agriculture to advertising. Government is another area where the potential improvements are obvious. After all, government is often defined by an abstract set of rules, transactions, permissions, and hierarchies. Software should be perfect for improving efficiency and transparency under these structures. In this episode, we explore OpenGov, a technology that is making just these types of improvements and is working through each of the bureaucratic negotiations, the integration challenges, and the technological bottlenecks that get in the way. But before we get to this episode, let's hear from a sponsor of Software Engineering Daily. I love being a software engineer because of how easy it is to build side projects, and I've built countless side projects. I've built a social gambling application, a dating website backend that had 0 users, a stock trading music rhythm application for Android, and I think every developer should have side projects. So when I have a web app that I want to deploy and share, I want to show my friends my most recent project that nobody will care about, I use DigitalOcean to quickly spin up a server and host my projects. And who knows, if one day one of my apps takes off and goes viral and people actually do care, I can easily scale using DigitalOcean's flexible pricing plan. Companies like TaskRabbit that have grown rapidly have used DigitalOcean for this very reason. But until this happens, I will happily stick with the $5 a month plan. Sign up with promo code SEDaily to get a free $10 credit as a listener of our show and start building your apps. We would love to see what listeners build, so send us an email showing us your project. I've also interviewed Moise Uretsky, who is the co-founder of DigitalOcean, and he mentioned that the ease of use and the flexibility is why they built the service in the first place. That DigitalOcean interview is one of my favorite episodes. Moise talks about bleeding in a data center. He says, you don't know how hard it is to do a cloud hosting service until you've bled in a data center. It's really interesting. So speaking of which, let's get on with this episode of Software Engineering Daily. OpenGov provides government performance intelligence and financial transparency. Andrew Clark is an engineer at OpenGov. Andrew, welcome to Software Engineering Daily.
Hi, Jeff. Great to be here.
In order to get an idea of the problem that OpenGov is trying to solve, tell me about the technology stack that most government offices are using to look at their performance.
So OpenGov, I guess, replaces kind of an amalgamation of tools. There are ERP systems, which frankly I'm not an expert in. I'm familiar with them because we have to be familiar with them, obviously, so that we're aware of the problems that we're solving. But I'm not an expert necessarily in the day-to-day. But I also know that a lot of the analysis work that government officials do is really just pushing numbers around in Excel. There are a lot of proprietary systems as well, or homegrown, built from the ground up solutions that governments use. There isn't really any direct analog to the kinds of services that OpenGov provides in terms of the full kind of stack of being able to generate these really in-depth reports really quickly and place them publicly online for anyone to see. That really just doesn't exist for the most part in governments nowadays. Unless they're using OpenGov, or we have a few competitors, but really nothing quite on our level. But yeah, it's mostly like traditional ERPs or a lot of Excel stuff.
Right. Okay. So we should get into more detail about what OpenGov is. What is OpenGov?
So we provide, you gave it a little bit in a nutshell. It's business and financial intelligence for governments, primarily, exclusively local governments right now. So anything from Washington, D.C. to Palo Alto, or just recently we signed my hometown in Florida, Pensacola, which is very small. So we have about 500 local governments all around the U.S. right now. And what the governments will do is they have all this financial information, all this transactional data that they will upload to our systems. And what we're probably most known for is that we will take that data and we put it into our system. We analyze it based on this thing called a chart of accounts. And we use it to generate these really nice online reports that are interactive, and anybody can log into the system or log onto a public website. Any citizen can log into a public website, and you can drill down into the different things that the government has spent on money on for X number of years.
So this is really like a qualitative leap in the interaction between citizenry and government, because in the previous type of government technology stack doesn't have any degree of this built-in exposure to the public.
Right, exactly. So this is definitely a leap in terms of what's possible to do easily without having to hire some person to build your own custom system. You can just use our platform. We're trying to make it easier and easier all the time, but it's relative to anything that existed before. It's very easy for governments to just give us their data, and they can go in and customize how they want their reports to look, and then very quickly you can have a public site available for citizens to look at the data. But that's just one service that we offer. That's how most people probably know us. That was our original product or offering. We're moving more into even more cool things that we're doing in terms of not just displaying the data, but offering analysis, offering ways to compare data against other government entities to try and find solutions so that governments can communicate with each other and say, hey, how did you guys solve that problem? I'm having a similar problem. How can I compare our data to other governments' data that are similar or maybe near us geographically? And then we're also moving into things like budgeting so that governments can prepare budgets and use insights based on all of the data that we've acquired over the years and can continue to acquire. And we have a really great team of data scientists that we're just starting to we're just really touching the surface of the really cool services and offerings that I think that will be able to in the future.
So I want to get into those different things, but just to hammer home the initial offering that you had, if I'm thinking about it correctly, so if I want to look at my finances, I use like mint.com or Quicken, or maybe I use TurboTax to process those taxes. And in business, I can use QuickBooks. So is this like an equivalent system for government, like a nice UI plus transaction and analysis system?
Yeah, I think that's a pretty good analogy. It's not quite to Mint level in terms of like you can start a Mint account today and immediately you can immediately start using it. It's not quite to that level. That's one of our goals, is we wanted to make it super easy for governments to sign up and be able to immediately start using the product. Right now it's a little bit more complicated. We have a really great team of a customer success team that we have an onboarding process for just because government finances are inherently much more complicated than someone's personal finances. You have money coming from all different sorts of funds and locations, and you have this very complicated chart of accounts describing how all the money is organized and allocated. But that's a pretty good way of thinking of it, is in terms of a Mint.com style solution.
Okay, you talked about this. The reason it's not quite Mint.com yet, and I think the root of that is this integration process. And tell me about the integration process that a government goes through as they're onboarding with OpenGov. Like on Software Engineering Daily, we've had some shows where you talk to software providers, and when they're engaging with a customer, sometimes they have to go through this integration process. So tell me about that.
It's still a work in progress. We have a team right now that's, and if I understand you correctly, you mean so government signs on and they have an existing system and we want to be able to just import their data from their system, right?
Yes, that's exactly right.
Yeah, so this is an ongoing thing that we're working on. It's a big focus for us right now. As up till now, it's a lot of it's been very manual, unfortunately. And so what they've had to do is, just because we would get it in so many different formats, every government would have a slightly different system for how they both stored their data and they had a different chart of accounts, and sometimes it was very complicated the way they did it and didn't quite fit with our system. So in the past, and we're still a fairly young startup, it's been a very manual process, and it's been one of the struggles or one of the challenges that we've had in trying to reduce the amount of time from, okay, here's your data that you've just maybe, for instance, dumped to us via FTP in a bunch of files, and now let's get it into a format that's usable on OpenGov. That can sometimes take weeks to months, depending on how responsive the government is. So integrations I'm glad you brought that up, because that's a big problem that we are solving right now in terms of creating a system where we can integrate with the most common ERPs or common financial systems that governments already have their data in, so that you have that mint.com like experience where you can just log in, you click a button to fill out a form to log into some external service, and we can just directly import it into our system. So that's not something that is totally fleshed out yet, but it's one of our top areas of focus right now.
Yeah, when I was reading about OpenGov, I was like, okay, this is awesome, but this is what stuck out at me as the most trying thing. That sound like the most difficult part. Like, certainly, there's challenges to making the mint.com gorgeous UI and importing the CSV and dealing with data integrity and stuff. But the problem that I think about that sounds really challenging is just like interacting with government people who may not be super tech savvy. They may not really be, you may not be dealing with somebody that's super motivated, and you're dealing with stuff like FTP, like you said. So I mean, what are the big challenges? Like, am I correct in thinking that this is actually like the really, really hardest part is this interrelation hurdle?
Yeah, I think that's a very good assessment of it. So I'm a mostly front end guy. So what I deal with most of the time is, so if I'm not offering enough detail, I apologize. We have kind of two separate challenges. One, there's just like make the nice web software application, make it very user friendly, make it so that the fire chief can submit a budget proposal without pulling his hair out and having to learn about Excel and all of these crazy terms. There's that challenge, right? Which I think we're doing a very good job at, and we can continue to do better. And that's where my focus is most of the time. And then there's this other challenge that you mentioned where, we're dealing with really, really complicated data sets. And we're dealing with a huge variety of sources of varying qualities of data. And it's large amounts of data that we're getting from it as well. And we need to be able to not only analyze that data, but just simply acquire it in a way that's not super burdensome, and we don't have to have this giant army of customer success people like constantly taking months to onboard our customers. So that's definitely a huge challenge. We have about 20-ish engineers right now, and I'd say like maybe half of them are dealing with either the data analysis and the data science and the just the data management part of it, and then also we have a team that's dealing with the integration stuff, like you said. So it's a very big challenge.
I mean, it's really interesting, this question of like, how much of the work do you try to offload to technology, and how much of the work do you try to offload to customer service? I did an interview with the co-founder of DigitalOcean, and he was talking about how the biggest component of DigitalOcean is their customer service team. And I probably Amazon would say something similar, where like that's part of how they succeed is they augment. Well, they would say they would augment their technology with people, with more and more people. But it sounds like you guys are really trying to figure out a way to minimize the amount of legwork that the integration specialists have to do. Or, I mean, obviously, like you said, this is not your specialty, and I don't want to be,
No. These are great questions. Yeah, I think you're right. It's not that we want to get rid of our customer success team. I think that's a huge strength of our company is we have an amazing customer success team. But obviously, if we have sign-up times or if if the time from signing a contract to public site is several months long, why can't that be like maybe a week long or a few days long? It's obviously a huge goal for us to get that down as small as possible in order so we can continue to grow as a company and focus on new problems rather than having to spend a bunch of time mired in this month-long process of, okay, did you get your chart of accounts to us yet? Or, hey, this isn't quite right. Hey, can you get the data to us? And especially like with governments, you can imagine they're not always, depending on the government, it's sometimes hard to get a response from someone. You have personnel changes, but from the time you sign the contracts to 9 months later, you can have a whole different set of people that you're talking to over there. So whatever we can do to minimize that time from contract signed to usable product is obviously good for both the governments themselves and for OpenGov as a company.
Is there any degree of standardization between the data formats that different governments have?
As far as I know, no, and that's one of the problems. I think we've discussed, and I don't know a ton of the details, we have discussed perhaps being part of an effort to create some sort of data standard, particularly for, not just for financial data, but for we also deal in non-financial data like government statistics, like like car accidents per. I'm pulling stuff out of my butt here, but non-financial data that we want people to be able to provide to people as well. We have a data science team that I know has worked really hard to come up with ways to ingest this data and put it into our system, and we have a really large, maybe the largest of its kind, repository of lots and lots of really useful information that we've pulled from census data and all other kinds of sources. And there really isn't, at least to my knowledge, there isn't any great standard for that stuff. I know I think we've discussed an effort to maybe provide or help create some sort of standard like that. And then also, I've mentioned this a few times, but there's this thing called a chart of accounts. I know another thing we've considered doing is a chart of accounts is essentially a tree-like structure that describes how money in an organization is allocated to different accounts and how those accounts relate to each other in terms of departments and funds and in this tree-like structure. Another thing we've discussed to try and make this a little bit easier for people is we see all sorts of chart of accounts, some of them effective, some of them less so effective. And so at this point, we have a lot of expertise at the company for what makes a good government chart of accounts. And so we've discussed perhaps something along the lines of providing a kind of an OpenGov standard for this is how, an OpenGov specification for this is how a chart of accounts should look.
Sure.
Or maybe even like we can create one automatically for government using all the stuff that we've learned from previous governments.
Sure. Okay. So we could talk about the higher level product stuff and the domain specific engineering aspects, but I think we should get into more general engineering topics since this is Software Engineering Daily. So to start, when a client comes online, when an OpenGov client buys a contract and their site gets spun up, what is going on in the back end? What kinds of technologies are you guys using?
So on the back end, we're using Postgres and a lot of Rails right now. We have several different components. It's been interesting. Before I was there, because we also have a very critical component of our app right now that's written in Node. Interestingly, I think at the beginning it kind of happened, and this probably happens to a lot of different startups, where we had this one component that kind of dealt with everything. It did the front end Rails views. It did several different data. We had several different databases and several different concerns that were all mixed
the monolith.
Giant monolith, exactly. And I'm not sure the exact timeline of how this happened, but eventually we started breaking these things up into microservices, right? So now we just have like a separate repo and a separate project for every single little thing at the company, every single little piece of our our front-end app was in this separate repo with separate people working on it. So we have like a transparency app, we have a reports app, we have a data uploading app. And so we kind of went the opposite extreme where everything just got siloed into different parts. And then now we're kind of going back towards more of a, maybe not a monolith, but we're kind of reacting against that because it got very complicated. If it's the idea of microservices is nice, but sometimes when you have things in a bunch of different separate repos, it makes it really hard. Especially, for instance, we had a bunch of different front-end repos. Even though they're all being combined together in when they were deployed, they were all being combined together into like what was supposed to be like a unified experience. We had 3 or 4 different front-end servers that we'd have to deploy. Every time we went to deploy, we'd have to deal with, it just became this versioning kind of nightmare. And we kind of experienced the other end of the spectrum in terms of splitting things up too much. So now we're going back to this, I think a much more, where we've started to move towards a saner approach where a lot of our it also helps that we've kind of solidified on our software stack. So now almost all of our backend stuff, or for the most part, the critical stuff is written in Rails, at least for now. And then all of our front-end stuff is a React, Babel, Redux, Relay kind of stack. And so we have one repo that does our Rails stuff, rather than 2 or 3, and we have one repo now. Well, it's not quite there, but we're moving everything into this one repo for all of our front end React stuff. But we even have some Backbone and jQuery stuff in there as well. And but we also have, so for the integrations team, I know they use Python a lot. The data science team uses Python as well. We still have this kind of legacy Node thing that we're going to replace with, I believe it's with Rails and Postgres. But yeah.
Okay, so it's really interesting hearing this vacillation between monolith to microservice, back to monolith, or back to somewhere in between monolith and microservice. Was there? I mean, do you think was there a mistake involved, or was it more just like it looked like a good idea at the time, and then oops, something changed? Or
I think it's more of a looked like a good idea at the time, and things. Yeah, maybe a little bit of both.
How many people were in the organization when you went from monolith to microservices?
It's hard to say. I actually just joined. Just for some context, I joined last May, and when I joined, I think there were about 15 engineers. So it wasn't that many, I guess, probably that we went from monolith to microservice, because by the time I joined, people were already starting to have this microservices fatigue. And I know I definitely did because the first week I started, I'm like, okay, how do I start pushing code? And I'd have to
well, it's a 20-step process.
Yeah, you gotta pull down these 5 different repos, and okay, which ones do I actually need? Which ones can I not pull down?
Oh no!
And I gotta start up which port does this thing run on? And it's or you can use the Chef Cookbook, which takes forever to configure. And so yeah, it not only was it a pain for deployment, but just for onboarding people, it became kind of very hard to. I mean, we still kind of have this problem, but it's definitely getting better, where it's hard for people who just start to get a grip on exactly all the different parts of the stack. Whereas now, hopefully, going forward, when we have this one front-end repo, it'll be just a matter of pull down the front-end repo. If you're not connecting to our testing server and you want to do it locally, then pull down this back-end repo. At max, you'll have 2 things running, and that's it. And there shouldn't be a whole... You shouldn't have to learn every single part of the stack in order just to get a basic development server up.
Whew, man, that microservice fatigue, that sounds tough. I did an interview with the chief architect of Uber, and he talked about microservice fatigue and talked about the motivation for whether you should move to microservices or not. And it was interesting because it sounded like it wasn't... he if I remember correctly, it was more he would advocate microservices being the reason I asked about the team size is he would advocate it being based more on your team size and how the org is changing rather than having to do with something about this, how complex your architecture is. Obviously, there's no one size fits all set of rules for microservices. But maybe if you have an extremely small team and you have a monolith, and the monolith is kind of like crufty and hard to deal with, that's maybe still okay, because maybe that's better than having a really complicated deployment and commit process.
Right, and I guess there's several components of it. One advantage of having a monolith, aside from there's the deployment part. There's also just the having one repo part. That's really nice. They're not exactly the same thing, monolith versus one repo, but it's nice to only have not to have to manage like version conflicts between two different things. There's just the cognitive. So just to give you a front-end example, this is kind of maybe a slightly trivial example, but if we have multiple different front-end apps and I have a single component that I want to share again, that I want to, I wrote it for this app, but maybe I want to use it in this other app. Well, so the way we solved that was, okay, we'll just have like a component library that lives like in a separate repo. I was like, well, now I got to update. In order to use this component, I've got to update like 3 different repos and open 3 separate PRs and test it 3 separate times and hope they all go out at the same time, just to use this one simple little component. And so what ends up happening is, screw that, I'm just going to not make it reusable and just put it in this guy instead of try and share it. And so there are a bunch of different layers to this problem. But I think we're moving in the right direction.
Okay, interesting. Engineers love automation, and Wealthfront automates your investing. As a software engineer, there are certain processes that you want to execute no matter what, like integration tests during a build. You wouldn't execute integration tests manually. You would use a continuous integration tool like CodeShip or Jenkins to automate your integration tests. Wealthfront is a tool to automate investing. Just like a continuous integration tool runs your tests automatically, Wealthfront can reinvest your dividends automatically and perform tax loss harvesting automatically. To get your first $15,000 managed by Wealthfront for free, go to wealthfront.com/sedaily and get started with Wealthfront's layer of automation on top of your portfolio. Wealthfront.com/sedaily. Check it out. It would support Software Engineering Daily, and you will get $15,000 managed for free if you sign up. Automate your investing. Get back to the things that you can't automate, like writing code. So Palo Alto Gov, let's take that as an example. So when Palo Alto onboards with OpenGov, they get their own site spun up. Is that correct? Like, is it their own Rails monolith that gets spun up on OpenGov servers, and then now I can go to paloaltogov.com or whatever it's called? Is that how it works?
We don't spin up extra servers. Like, you don't have like a dedicated server.
Okay.
It's all running on our system. You do get your own website, you get your own URL, right? Like paloalto.opengov.com. But no, it all runs on the same set of servers.
Okay. So is it the same Rails application that people are accessing?
Yeah, it's the same Rails application.
Okay, I see. So are you using AWS?
Yes, we're completely on AWS.
Interesting. Okay, cool. So we should talk more about the front end, since you are basically a front end developer. You focus mostly on the front end. So you've talked about the it started out as I think Rails. You said Rails and you said Postgres, obviously, but and I know you mentioned Backbone, so I'm guessing the Backbone was there before the React. Is that correct?
So again, I might get the timeline a little bit wrong, but I believe the way it went was we had, and there's some overlap as well, because we'd have different teams of different people working on front-end stuff at the same time. So in the beginning, it was Rails, and then we added some jQuery in. So we still have like some very critical components of our app that are still written in this amalgamation of like a Rails views plus some jQuery sprinkled on top. And then we moved after that. we experimented with Backbone a bit. So I don't think we really use Backbone for that much anymore. We have a React app where we're using Backbone models.
Okay.
But I don't think we stayed on Backbone for that long. And then now pretty much everything for the last maybe year and a half has been a React and Flux app.
Okay, great.
But there is still the data science team has an app that they came out with recently that is still written in jQuery, just because it has been in progress for a while and it never made the leap to React. But yeah, we have but mainly centered around React going forward, but we still do have some legacy stuff that's written in jQuery.
Okay. So according to your Twitter account, you are, quote, currently living in React/JavaScript/Node land. How does that land contrast with other software development paradigms you have worked in?
Well, okay, so this is actually my first job, my first software engineering job I've ever had, so I can't say I have a ton of experience in other stacks.
Well, certainly you worked, you did programming in college or whatever, high school before that, so...
Yeah. So could you repeat the question real quick? Sorry.
So I'm just curious, like, how does your experience, how does your workflow compare to other software development paradigms that you've worked in when you're using React and JavaScript and Node?
My workflow, I guess.
Or is this all you've ever worked in, literally?
This isn't literally all I've ever worked in, but in terms of like actual, like on a team, day-to-day, certainly being paid for it, software development, this is, I've always done web stuff. So I guess if I compare what I'm doing now to maybe what I was doing on the web like 2 or 3 years ago, where I used to do like maybe contract work, or before I was like a proper programmer, I would do like, WordPress sites for people. Or before I had this job, I had like a job at a digital agency where we would make kind of marketing sites and branding sites for people. So, and then I've made an iOS app before. I'm not sure if I could quite compare that experience to this because it was like that was literally the first piece of software I ever wrote, and it was really fun, but it's not quite the same thing because it's more like late nights of caffeine-fueled coding versus, not that there's no late nights here, but it's more, like a more proper professional environment.
Well, maybe, one thing that's interesting, maybe this relates to you, maybe it doesn't, but, I had a conversation recently about object-oriented programming, and the person I was talking to was Brian Kernahan, that's who it was. His show is going to air soon. He's been around for a long time, and he said that, he wrote a book on C, like K&R. It's a pretty famous book, but he said that, his understanding of object orientation, for example, is very rooted in his understanding of C and Java and how object orientation works in those. And therefore, he doesn't have much of an understanding of how the JavaScript object orientation model works. Whereas I have met younger people, 20, 21, 19, or whatever, all their work has been in JavaScript. And their notion of how object orientation works is totally based on the prototype model. So right. I'm curious if that resonates with you at all. Like, or do you even think about object orientation as a JavaScript programmer?
Okay, I kind of see where your question's coming from. Maybe now. That's interesting because the first language I ever scripted in was JavaScript, or coded in was JavaScript, like just little silly web page scripts. But the first proper language I ever learned in college was Java, which is very much the classical object-oriented pattern. Yeah. And then the very first kind of software project I ever completed and like released was an iOS app where Objective-C is also a very much on the opposite end of the spectrum from JavaScript in terms of like this is very strict for the most part. Like class-based object-oriented programming.
Sure.
When it comes to JavaScript, I've never really been one to like take advantage of the prototype chain or like make. It's never been like a huge part of the way I've coded. Maybe when I was like making like jQuery plugins and stuff, But the thing I've always liked about JavaScript is not so much the prototypes or the object-oriented side, but the other kind of half of JavaScript, which is closures and lambdas and functions and kind of the more functional side of dynamic side of JavaScript. And that's the wrong word, but the more functional side of JavaScript has always been the thing that's attracted me, especially since I've been using React, because that clearly gels with those concepts really well. So when most of the code I write nowadays that's in JavaScript looks very, maybe too much sometimes because I have like Elm envy, but it looks very a lot more functional versus object-oriented. Unless I have to, I rarely am adding things to a prototype chain or using the new operator. For the most part, the code that I write tends to stick to the more functional paradigm.
So yeah, I mean, Elm envy, interesting. Okay, so many developers talk about Elm and Ohm as being languages that are maybe leading indicators of where React might go or where programming in general might go. And I think you've talked about this a bit. So what is it about Elm and Ohm that are so appealing?
Well, I think I would agree with that statement that they're kind of leading indicators. I haven't written a ton of stuff in Elm or Ohm or ClojureScript, I should say. But I've just kind of done side little playground things. But they're fascinating to me because all the things that I like about that like were really like epiphany moments for me when I started using React are just like that was like it's almost like that was a taste. If you want to go to the promised land, then you use ClojureScript or you use Elm, which in my day-to-day work is not likely anytime soon for many various reasons. Practical reasons, just hiring reasons, and it's totally fine because for the most part, I actually enjoy writing in JavaScript a lot. I'm not a person who hates JavaScript. I have a mostly very pleasant time writing it. But I really like, maybe just because it's also just I still consider myself very very young, naive, and inexperienced programmer. I'm constantly wanting to learn new things, and these more purely functional programming languages like Elm really excite me because they have all these concepts which I've only gotten to dabble in with JavaScript, but look really cool. Like I really like the idea of strong types. I know that's like a contentious thing for a lot of people, but it's one of the things I really miss. I didn't really like Objective-C, but I really missed having types in Objective-C or in Java. And just playing around with the type system in Elm, or I've dabbled a little bit in like Haskell a little bit as well, too. I think that's a really cool component of Elm.
Where do you find types helping you out? Is it at like when you're working in the IDE, or is it at compile time, or what exactly?
Both. I mean, so just again, I'm not an expert in this stuff, but it's just my impression that if you're trying your best to write, and I'm thinking in the context of like creating UIs or creating front-end applications, if you're doing your best to follow best practices and keep your UI code very pure and try and push your side effects and your and that type of stuff into these separate areas and keep your UI code very pure and predictable and testable. If you're already writing code like that, which I try to, then adding static types just gives you this extra level of clarity and certainty that your code isn't going to do crazy crashy things at runtime. So just maybe for a brief example, JavaScript doesn't have static typing, but we have things like TypeScript and Flow. So we started adding Flow to. Do I need to explain what Flow is, or do you think most people know?
You could put 2 words on it. I know what it is.
Yeah, so it's an incremental static typing, kind of like TypeScript, but it's provided by Facebook, and it's not really. I can't say it's popular, but it's has some, I guess, usage in the React community. You just add these incremental type annotations to your JavaScript files, and you run a Flow server, and it just checks to make sure everything type checks properly.
By incremental, you mean optional?
optional, and not nearly as it's nothing on the level of the very strict algebraic data types that Provides, but it's better than nothing, I guess. So we, at least for some things, so we've started to add flow types to several of our modules in our app, and even beyond just, I'm not sure how many errors it's caught. I do like it when I'm coding because sometimes you make a silly mistake and you return the wrong thing. Or I feel like it probably does catch some things like that. But really, I just like it for the self-documenting part of it. Like I don't have to I don't have to go just by like the variable name to try and figure out what this is. This an ID or is this the object itself? We have several we have several modules in our app that have to deal with traversing these tree-like structures. It's like the COA again. And I was reviewing someone else's code in this, by no fault of their own, because it's just inherently kind of complex logic that's going on. That's very crucial to how our product works. It was just very hard to follow because it was just a bunch of variable names, and it was there were comments, but it was sometimes even just describing things in words isn't always the best way to communicate what's happening. But we went in there, we put some flow types in, and it made it much easier to figure out what was going on because we could see exactly which objects and which pieces were being passed around to different parts of the different functions.
Yeah, it's interesting this trade-off between the incremental or optional type system and the more oppressive, or maybe oppressive is the wrong word, but the Elm type system or Haskell type system, whatever, forcing you to type it. There's the question of, if you're going to use a type system, why wouldn't you use it everywhere? But maybe you don't want to use it everywhere.
Yeah, I have to say, maybe it's just a temperament thing or a matter of preference. I am the type of person who probably would want to be forced to put types everywhere. Like that's just kind of who I am, I guess. It just gives me a nice fuzzy feeling. Maybe I liked math a lot in school. Maybe people who are more math inclined like.
You're responsible. Have you ever gotten a speeding ticket?
I got out of it, but I did get a speeding ticket. Okay, I don't think it's a responsible thing either because I'm not the most responsible person. But yeah, I just like the idea that everything fits together and the compiler can make all of these, can check all these things for me without me having to cross my fingers and hope it works. I like letting the compiler do as much work as possible. But I can see how it can be, some people feel that it's constricting or limiting, and you just want to code and you don't want to, you know what you're doing, you don't want the compiler to be yelling at you all the time, or having to do your homework, I guess, by documenting exactly what types you're using. Okay,
so Flow. I mean, we're talking about Flow at this point, but there's also, on Software Engineering Daily, we've done a bunch of shows about React. We've done a bunch of shows on the suite of technologies developed by Facebook and developed by the open source community that are kind of related to React, like GraphQL, like you mentioned, Flow. When you're working with these tools, and I don't know how many of them you work with, do you think of them explicitly as a front-end framework, or is there something deeper to it? Is there a broader paradigm shift in how we are thinking about application development?
I don't know, because I don't really think, I definitely am mostly a front-end programmer, but I guess I don't think of myself that way. So I guess GraphQL is a good example. We're using a GraphQL relay wrapper around our legacy REST APIs right now. It's actually, we started doing that for recently for one of our apps, and
that sounds super interesting. Can we deviate and talk about that?
Oh yeah, we can talk about that. If I can just finish this thought.
Sure.
I guess if I had to, because I wish I had a better way to answer this, but I feel like that question was really good. I consider Flow, GraphQL and React especially are they are very similar. I'm trying to articulate how, but
is the idea of the front end programmer, is that being sublimated into the idea of the middle tier application developer?
I think probably. maybe another way to think of it is that like if you write an iOS, like if you make iOS apps or Mac apps or Windows apps for a living, like you don't really call yourself a front end developer, right? But if you're if you're making web apps, there's still sometimes this distinction between you're a front end developer, and sometimes there's that negative connotation that comes along with it. But really, yes. I think front end developers are just becoming like app developers that happen to be rendering to the browser versus an iOS app or an Android app. So I never feel embarrassed to tell people I'm a front end developer. And I think you're right. I think it is maybe evolving more towards instead of being like a front end thing and a back end thing, there's like this middle area where maybe that middle area is just calling it just straight up app development rather than front end web developer.
Yeah, or the the unicorn full stack developer, as so many job listings call it.
Yeah.
Okay, but you mentioned this GraphQL wrapper around your legacy REST APIs, and we did a show about GraphQL, and it'd be great to hear about how you are using it in the wild.
I don't think we're using it totally differently from how other people have started using it, but we have these legacy REST APIs. This is actually a little bit of a point of contention, which I might get into, but we have these legacy REST APIs. We started making this app I guess it was in August. We started making this new app, which is very important to the future of the company, like strategically important, and we're going to be maintaining it for many years. So we were trying to make, and we had kind of a chance to start from not nothing, because we still have our existing other services that we're integrating with, but we had a chance to at the beginning really try and get it right architecturally and technically, since in the past we've had these problems of constantly changing stacks and constantly changing technologies, different Flux frameworks and all that type of stuff. So we started with using Redux, which is a Flux framework to fetch, to do all of our data fetching in the beginning. And we had kind of our eye on maybe a Falcor or a Relay, because those were at the time just starting to be open source and released and people were using them. But when we first started this app, they weren't technically publicly available. So we started just doing a Redux app, and we kind of got into the same problems that I personally have always had with any kind of Flux type of system for data fetching, which is that I feel like Flux is pretty good and Redux is really good for application local type of state and application level state. When it comes to data fetching, it's always just felt hacky to me, because you have these stores, or you have this store with these reducers, and it's pretty straightforward to fetch it in there. But then you got to add things like caching, or what if you want to do pagination? What if you want to deal with overfetching? And so when I saw Relay last year, I was like, aha, that's exactly the type of thing that I want. So eventually we were like, okay, we really want to use Relay because it solves all these problems that we keep having to solve over and over and over again. But we don't have a GraphQL backend, we have a REST backend. And so I don't think this is that unique of a solution. I think other people have done this as well. So the solution we had was, okay, we have these node servers anyway that are just kind of serving as these front end serving. They're very lightweight and they just serve our front end stuff. Why don't we just put a GraphQL wrapper around our REST APIs? And so we're talking to this GraphQL server, and as an implementation detail of how the GraphQL schema is set up, it's making the whatever REST calls. But our client doesn't need to know about that. It's just consuming GraphQL. So that's what we did, and it's actually worked out well. There was some contention from the backend guys, really worried that we were adding this other confusing layer in between. We probably could have been some better communication between the front end teams and the architecture back end teams about why we made that decision. I personally think still think it was the right decision to make. I know there's some people who are still questioning whether or not the trade-off is worth it. But I'm just such a huge fan of GraphQL and also Relay that it's been an amazing way for us to be able to focus on product development without having to constantly rethink resolve all these caching and pagination and really gross problems that we always inevitably ended up having in these Flux type apps. But yeah, if you want to know specifically how this REST wrapper worked, it's really not that complicated. So the nice thing about GraphQL when you're creating the schema is that it's completely agnostic to what kind of data backend that you have. So you have these you have this schema and you have these fields that correspond to this schema, and for each field you get a resolve function, and that resolve function returns data for that field either synchronously or asynchronously. So in those resolve functions, rather than fetching directly from a database, we just fetch from a REST endpoint, and that's pretty much it.
Right. Yeah, that makes complete sense. That was an awesome explanation. So I want to talk about your upcoming talk at React JS Conf in February. Your talk is called Back to React, and I guess I should take a moment to thank the React JS Conf because they gave me a ticket and I'll be there.
Awesome.
Yeah, I'm really looking forward to it. So I'll be reporting, I guess. But what are the topics that you're covering in that talk, Back to React?
So the talk, and I haven't written it yet, but the
putting you on the spot.
Yeah, I started outlining it, and it's because I submitted 2 proposals, and this is the one. I'm glad they picked this one because this is the one I liked more. But it has a lot to do with some of the things we were talking about earlier in this talk. I'm really interested, and I think a lot of people are really interested in what I like to call these kind of post-React libraries / architectures / languages that have kind of emerged since React has come onto the scene. Because I think whether you're a React user or not, if you're using Angular, Ember, or Om, or Cycle, or Elm in the Elm architecture, it's kind of inarguable that React and its virtual DOM architecture and its component-based architecture and this declarative view pattern has kind of changed the way that UIs are built for the web, and even now with React Native and stuff like that, even probably for UIs anywhere on any platform. And I'm super interested in these post-React libraries and languages like Elm, like Om, but I can't necessarily, doesn't mean I'm necessarily going to use them. Again, for like various practical reasons, or I want to use Relay, and I don't want to give up Relay, so maybe that's not enough for me to. It's not like the static typing of Elm, for instance, might not be enough for me to give up Relay. I still want to be part of the React community, but I look at the like Elm and Om and these other libraries and frameworks with this envy, and I also feel like there's some really valuable things that we can learn from these more purely functional libraries and frameworks. And the idea of this talk is I want to show how some of the key insights that I've taken from these post-React frameworks, how we can apply that to React today, and how we can use those ideas to make our current React applications better without having to actually give up React.
And so one of the effects of this React paradigm that I think you're kind of hinting at, you've said that Ember and Angular have pivoted in the wake of React's 2 big innovations, which are the declarative component model and the unidirectional data flow. What are the ways in which Ember and Angular have pivoted?
So I believe again, I'm not an expert in either Ember or Angular. I've just read through the through the descriptions of both of the new. There's Ember, whatever version it is, Ember 2. They have a new Glimmer engine. And then Angular 2 also is post-React. So Ember's Glimmer engine, as far as I can tell, is a pretty straightforward, not copy, but pretty straightforward implementation of the same kind of idea that React uses in terms of how it's a component model where data flows one way. If you even look at their version of the lifecycle methods, they have this table. I wish I remembered where this was, but they have this table saying, here's the name of the lifecycle method in React, here's what it corresponds to in Ember. And they're very open about it. It's a very straightforward kind of port, maybe you could say, or directly inspired by React's component model, which I think is really cool that all these frameworks are able to learn from each other and move towards these better architectures. Angular, I don't think they've quite moved to a Glimmer style or VDOM style component architecture quite yet, but at least my impression is that it does seem like they have adopted the unidirectional part, where there's less emphasis on two-way data binding, and it's more on you give a view some data and it composes another view which gets data and it goes in one direction. I'm not a huge expert on that, but at least that's my impression from having read about Angular 2 and like blog posts and stuff.
So shifting the conversation back to OpenGov and back to large-scale application development, now that we've touched on React a bit, I imagine that as you're building this OpenGov platform, you've got, for example, these three big products. You've got OpenGov Intelligence, you've got OpenGov Comparisons, and OpenGov Transparency. I imagine there will be more in the future. And as you're building them, I imagine that you want your React components that you're using in one to be reusable in another. Is that assumption correct?
Yeah.
So what are the challenges to building the components in a properly modular way where they're reusable and composable?
So, yeah, this is a challenge, and it's something that's been hampered in the past by that problem I described earlier, where we had like many different repos for our front end stuff. So now we just have one repo, which we started migrating everything over to, and it's started to improve the problem. I think I also mentioned that we had this separate library we call it Ovid, which is just a component library that we have for all of our mostly user interface components. That's not the only type of component we like to share, but it's the most, I guess maybe the most obvious type is just user interface components. We want to have a nice consistent interface across all of our products. And so we have like a very basic version of what a lot of companies have, which is a component library where you have these base set of components for like buttons and forms and sidebars and stuff like that. And if you want to make a change to one of those, you want to add a new one, you add it to this component library first. That way any app can benefit from either the enhancement you made to an existing component or a new component. So we do have something like that. Again, it's been the potential of that concept has been hampered in the past by the idea that we had like 5 different repos, and every time we wanted to update that component library, we had to make sure we bumped the version on every single repo. But we haven't totally nailed it. I know that companies like Facebook, have like really cool versions of this concept that even like they have back-end versions of this as well, and they have. I've seen it. You can like search through the thousands of components that they've written. We're nowhere close to something like that. But beyond just UI components, we also have like more functional, not like functional paradigm functional, but like more functional pieces that we like to share across different apps as well. And that's become a lot easier because we have just this one repo. We don't have to deal with that versioning problem of having to bump an external project every time we add a component. And then we also have going completely away from React components or any kind of UI component. We also have these shared modules. So that module I was talking to you about earlier that deals with chart of account tree manipulation. It turns out that code that I was writing with my coworker a few months ago, that was kind of hard for me to piece together until we added the static types. Which it turns out that the code we were writing then has been written by basically every team at the company for as long as the company has existed.
Oh, no way!
Because it's very crucial to how our product works, and almost every repo backing their front end has some version of that code, and it's a thing where it can't just live in one place because we can't afford a round trip every time we need to calculate this thing. So it needs to live on the front end and the back end. and it needs to be like in Python and Ruby because we have both types of projects. And previously, when it's been done in another app, because when we were trying to figure this out, we talked to these other engineers, and he showed us his version of it, but it was like entangled in this jQuery mess, and it wasn't quite extracted properly so that we could actually use it. So obviously, this is a problem. Again, exacerbated by the fact that we had these different teams working on different apps with different stacks. But now that we're in this, I keep going back to this idea, but now that we're in this one unified front-end architecture, when we and another funny thing is while we were talking about this, the guy that sits across from me, Gurdas, was kind of overheard what we were talking about, and he's like, guys, come over here and look at this. And we go to his screen, and we're looking at basically the exact same function that he's working on at the same time. So yeah, that's another problem that we're fixing. So now we actually do have in our repo, we have a single file. It doesn't have everything in there, but we have a single module, multiple modules that have these common functions, and we're going to try and do a much better job of keeping these in one place, writing some really good tests and documentation around it. And then we've even talked about maybe finding some sort of language that we can cross-compile to both a backend library and also a front-end JavaScript library. That way we can maybe even share it across backend and front-end. We haven't done that yet, but we've talked about it.
Okay, the microservice monolith stuff rears its head again. That's super interesting. Yeah. Okay, so I want to close off with just circling back to OpenGov, because most of this conversation centered around the discussion of the engineering and React and stuff, but and even the integration discussion. But I want to get back to the high level just to close off and get an idea for what are the future products that OpenGov wants to build, and what is the big vision of OpenGov?
Well, I'm not sure I'm really allowed to tell you the specific products we're working on. I can tell you, because I've already kind of mentioned it, I think I'm allowed to tell you that the product I've been working on for the last few months is a budgeting product. So this will move us more towards that Mint.com style model that we were talking about. So I'm pretty excited about that because it's in alpha release right now. So we have a few, or alpha, I don't know if it's beta or alpha, but we have a few beta customers right now that are trying it out. We've gotten some really great feedback, and we're really excited about that. Once that's available for once that's in general availability in the next few months, it'll be one of the biggest parts of the company, and it'll be really exciting. I'm not sure I'm allowed to tell you specifically things we're working on beyond that, but it's very much in the area of, I think one of the two of the big focuses this year are just polishing everything up and making things a lot, just really bringing the user, putting an extra emphasis on the user experience and integrations as well. So I guess those are two separate concerns, but in my mind, they're kind of similar. Working on the integrations problem, like we talked at the beginning of this talk, in terms of onboarding government so that we can get their data from wherever it is currently into the system really quickly so they can go from contract to usable product as fast as possible. And then also just making the user flow in terms of using the app really nice so that not so that we can get rid of our customer success team, because they're a huge part of why this company is successful, but so that we don't have to have this month-long ordeal of going back and forth just to get something set up for them. Right. So that's one focus. Another focus is we have this amazing data science team that we've put together in the last year, particularly, or the last few months, frankly, particularly, that is going to start infusing data science into every single part of the application. So, for instance, if you're in the budget application, when you're going to make a new proposal for next year's budget, we can put information right next to you, suggesting, hey, this is what maybe other governments near you are doing with this money next year. Or, hey, based on your historical data, here's a suggestion for things that you might want to do next year. That's one example. But we have so much data right now, and we're getting more and more data all the time, that data science, I think, is going to be a really important part of how OpenGov's products evolve in the future as well.
Well, that's fantastic. And OpenGov is a super interesting product, and I feel like we could do a whole week of shows about gov tech stuff. It seems like it's exploding in popularity and actual deployability, because I think there's probably increased adoption at the government level. Anyway, well, Andrew, it's been super interesting talking to you. I will definitely hit you up at React.js Conf and certainly give you a Software Engineering Daily t-shirt.
Oh, yeah, that'd be awesome. Yeah, thanks for having me on.
Absolutely. Thanks for coming on.